Hello, my name is Rose Rosso, and today we'll be detailing how to do Part B calculations for Experiment 9. Alright, so we're going to do pH after acidization to buffer. We're going to do 20 drops, 30 drops, and 40 drops. And then the other part of the calculations. So you're going to start out with 0.001 liters of HCl, and then you're going to multiply that by 1 mole HCl over 1 liter solution. Then you get 0.001 mole of HCl. And then you're going to take that number and you're going to add it to that starting amount of CH3COOH to get 0.021 mole of CH3COOH. And then you're going to subtract it from this number you got right here from that CH3COONA, and you get 0.019 mole of CH3COONA. So now we're going to put it into M, and we're going to do this number you just calculated over the total liter solution, and you get 1 m of CH3COOH, and then you're going to put that number you just calculated right here over that total solution. It's going to be a little bit less than 1 because they're not equal, and you're going to get 0.9 of CH3COONA. So now we're going to calculate the pH for that part. We're going to do pH equals pKa plus log of A over HA, and the pKa is 4.76, so you're going to do plus this number you calculated right here, 0.904. I just use this to get a more accurate result, and then you get over that 1 right here, and then that's 4.716. Now for after 30 drops of HCl, you're just going to add 0.0005 to that one because it's obviously more liquid you're using. And then we're going to put that into moles of HCl. You're going to add that to the moles of CH3COOH and then subtract it to the moles of CH3COONA, and you get 0.0215 mole of CH3COOH, and then you're going to get 0.0185 moles of CH3COONA. So now we're ready to calculate that M, and then you get 0.0215 of moles of CH3COOH over that total. Then you get 1, and then you're going to do this number you just calculated over that total. They're not the same, so it's going to be a little bit less than 1, 0.8604, and then we're going to calculate the pH from that. We're going to do pH equals pKa plus log of A over HA, that's 4.76, plus log of this number right here over that number. You solve that out, and then you get pH equals 4.694. To solve for that 40 drops, you're going to do the same process. You're going to 0.002, and then you're going to put it in the moles, then you're going to put that, add it to the CH3COOH, and then subtract the same number from that CH3COONA, and then you're going to put that over the total solution, which it comes out to be 1, and then 0.8181, and then you get ready to solve for that pH. That's pKa plus log of A over HA, and then you get 4.76 log over this one, or log, and then this one over this one, and then you get 4.673. And now to do that pH after base addition to buffer, you're going to do that same equation for pH, except for you're just going to flip the A over HA. Instead it's going to be HA over A. So then we're going to use those same numbers that we did calculate for the last part. It'll be 1 over 0.904, and then it gives you 4.803. Same process for 30 and 40. You're just going to use 1 over 0.8604, and that gives you 4.825, and then same thing for here. You're just going to use 1 and then 0.8181, and then you get 4.847.